Good afternoon to East Coast, and good evening to those of you joining us from Europe. Uh, we are, let's see, I'm Michael Rissi, I'm Vice President and CMO with Seeq, and Brian Crandall, Principal Analytics Engineer with Seeq, are with you this morning. We're going to present some case studies from recent OSIsoft user conferences where our customers have been presenting their use of Seeq to answer analytical questions about their production data, OSIsoft in particular. So as you can see, we were at the recent Florida Regional Summit here in the United States. We were recently in Germany at the OSIsoft User Conference in Berlin, and most recently at the OSIsoft User Conference in San Francisco. And so the stories we're going to talk about today are use cases that our customers presented. Most of these, or two of the three, are available on the OSIsoft User Conference webpage. So if you'd like the full hour-long presentation presented by the customer on their use of Seeq, those are available to you and those are public. But what we wanted to do is pick out some highlights of the different use cases and share with you how Seeq customers are using Seeq to get faster insights and more value from their OSIsoft data. So on the next slide, you can see that there's a number of ways that Seeq and OSIsoft are working together. Seeq is an OSIsoft ISV partner, but there's also a number of points of integration between the Seeq product and the OSIsoft offering. So Brian, if you'd like to touch on those.
Yeah, thanks, Michael. So the purpose of Seeq is an application to help engineers, scientists get more value from their data, and OSIsoft, being an industry leader and capturing that data and storing it, we want to help our users get as much value from their Pi investments as possible. So that's number one. And the way we do it is you can just leave the data right where it is. We index all the data from your OSIsoft Pi historians. There's no need to move it around. You don't need to put it, anywhere else. If it's already there, it's being historized. It's good, just like it is. We just simply index it, connect to it, and all the infrastructure you build around it. If you use AF, you do event frames. If you have Pi notifications, if you're a heavy user of CoreSite, what we do is we can bring all that data in, allow the engineers to work with it very quickly instead of using, spreadsheets and going to other applications, writing complex relational database queries and all that stuff. And you get the insight, and then from there you can put it back into your OSIsoft Pi infrastructure. Like I mentioned earlier, Pi notifications, you can go to the CoreSite. So like Michael said, very closely tied with OSIsoft as a partner. So I'll just give a quick overview of the Seeq architecture and how we do that, how we fit in. At the top level, you can see that that's the Seeq screen that you'll see here in a little bit when we go into the use cases. That's how we present the data to the user using a web browser, and that's the screen that engineers, scientists use to get inside the data, to work with it. And from there, we can export into other tools, what other visualization tools that users may have. They may have invested a lot in already, and we want to plug into that as seamless as possible. For example, Pi CoreSite or Pi Vision, as it's being rebranded by OSIsoft. So you can take it there. You can use other tools, Tableau, Microsoft Power BI. You can also use the usual Office applications like Excel, PowerPoint to get the data and view it once you had it. But you've already worked with it. You've already done your analysis. You've already done all the hard parts, which time series data makes hard, because time series data very hard to work with, cumbersome to work with. You can do that and then go to those other applications. And then moving down in this diagram, we sit on top of a Seeq server. So we have a server. It's dedicated to Seeq. But that server is just storing the relationships, doing the calculations, connecting to the data. And we have programmatic interfaces that you can see off to the right with SDKs for your favorite programming language, C#, Python, Java, MATLAB. And then at the bottom of this structure here, we show all the connections we have. And OSIsoft Pi is the big process data historian for all your operational data. And then if you have other data as well, we can bring that in to help put context around that. So SQL, OPC, so forth. So that is the overall architecture. And I want to just set the table there as we go into the use cases. This is what what our users deployed at their facilities, and we're able to use it to get insight. And so I'll go through some of those now. So by the way, I just want to make a disclaimer here that these presentations and the slides that you see pictured on here are all public. They were presented at OSIsoft conferences, and you can refer to them on the OSIsoft website. And there's a link at the end of this presentation. We'll talk about that again. And then the second disclaimer is that as I go through and describe the use cases, I'm using some mocked up data on my system. It will follow the same process that our users used, but it's not the actual data from their site. So obviously want to protect their data. And so that's important. So as we go through, any customers who are on this call, you're not actually looking at real data, which should be a good thing, and as you'll see. The first use case, as I'll describe, Bristol-Myers Squibb, they presented at the last users conference here in San Francisco. And the purpose, or the main point that they wanted to address was automate their calculation for what they call peak symmetry in their purification area. And what they do is they pack these columns full of resin, and they want to make sure that it has a good quality, so they use this calculation to do that. And the interesting thing here is they were using actual paper to do these calculations because it was just too hard to see the intersection and the way the data came together. They actually had to do it on paper. Doing it digitally in an Excel spreadsheet or something like that didn't really help. And I'll show you why as we go in. So let me pop over to my Seeq application here. We'll actually go through in real time. Real live demo here. Again, not using actual customer data. This is mocked up, but you'll get the idea. So one of the things that I'll use here as we go through is a new feature that was introduced in Seeq version R17, and it's called a journal. And I use the journal here to describe what I'm doing, the analysis here, and I created this journal. And I can click through, and we can show you how to use this. So our customers can use it in a similar way when they do their analysis to collaborate, summarize, and share with their colleagues and management, and so forth. So here, what you're seeing is the final result of this symmetry analysis here. And I basically did a symmetry analysis on each of these three peaks here, and gave a result at the bottom in the bar chart there. So you can see not very symmetrical. So that's what I mean. It's a good thing this isn't actual real data. If you were a pharma user, this would be very concerning to you, but I wanted to show you, you'll see why I did that, just to make it obvious what was going on here. And then you can click on this link here, so as you can see, I can just click on links here. I can see how the symmetries were calculated by looking at these, what we call capsules here. So let me walk you through what we did here in Seeq, and I can just do this using this journal here. So let's follow the steps. Step one, I started with a blank worksheet because that's sometimes how we start, with a nice clean sheet of paper here, virtual paper that is. And let me add the signal that we want to analyze on the trend here. So here is one UV signal here, in my case, using this data here. And in this case, I want to find the peak, and we use a value search in Seeq. So I'll just click on the link here and show you the result of that value search here. What we get is these things called capsules that appear on the screen. So let me drag it out so I can see all peaks. So you see here that I was able to identify these peaks with the value search using that tool. The tool is over here in our tools pane, in this case value search, and identified 3 peaks there. Next, I was able to calculate the baseline average. And what the baseline average is the average of this signal 1 hour before this peak took place. So what I did is just took an hour before, and you can see it's near 0, and the value on this blue line here, you can see it's actually really close to 0. It's 5e to the negative 11, pretty much 0. And then what I did, using a formula, is calculated the 10% value between that 0 and that peak to get that green line down here at the bottom. And you can see it's about you know, 0.1. And the formula that I documented in the journal. And then we put these on the same axis here. So I just click on that link here. And if I click on the next link here, just to show you how we were calculating this, to do the left side and the right side calculation, this is where it got interesting and why they using Seeq was very helpful instead of using like paper printouts. Because let me zoom in here. I'll go to step 8 here. I'll just zoom in a little bit more. What they wanted to find were the intersections where that 10% value intersected the actual signal, calculate the time on the left side till it reaches that peak, and then do the same thing on the right side as well. So you can see why, in some cases, using a paper printout would be the best way to do it, is because it just takes, you know, to try to do this digitally, you know, in a spreadsheet, it's just hard to do. It's, you know, it's better to visualize and see it. And so we're able to do that very intuitively with Seeq. You can actually see it right there on the screen. And then what we did, right, in this case, my dummy data, is I created the calculation to take the ratio of the left side divided by the right side, and I get my 21% here. And I believe, I'm not a pharma scientist, but I believe 100% symmetry is what you're after here. So that's why it's good I'm using dummy data here, otherwise it'd be a little bit concerning. But then you can take that analysis and apply it over your range here. So my peaks are not very symmetrical, but you can see you get a result here, and you can you can apply it to anywhere else in your facility to help move those calculations along and save your scientists and engineers a lot of time. So that was the use case here, and I'll pause here for a second and see if there are any questions, or Michael, do you have any questions you'd like me to touch on there?
Well, I guess the key thing is, obviously, it's 2017, so anything's better than paper. But typically, Seeq customers are trying to optimize some production outcome. They're trying to optimize yield, quality, margins, safety. So this was a more productive solution than what had been used before. But what was the outcome from the business perspective that Seeq resulted in?
Right, yeah. So the outcome here, and what they're really trying to drive at, is help improve quality. So that symmetry being having a nice symmetrical signal was indicative of having a good packed piece of equipment, in this case chromatography column. And by applying this to do that, they're able to see that everything got packed appropriately. They can do it over a wide range of data, obviously save time, productivity for the engineer and scientist, but really drive to improve quality in their process. So it's a quality improvement situation.
Got it. Okay, let's take a look at Abbott.
Great. Moving on to Abbott. So this one was presented at the European conference, and the goal here was to excuse me, optimize their weight control for their packaging application. So they want to reduce the overfill and make sure that they're optimizing that process, not having any scrap or anything. And the way that they used to do that process or calculate those overfills was by spending time in spreadsheets and doing those calculations there. So they were able to use Seeq to automate those spreadsheet calculations, and I'll show you how they did that. Let me pop over back into Seeq, go to my other workbook here. And this is a case where, again, dummy data, not using actual Abbott data here in this case. So I want to make a disclaimer of that because actually it could be indicative of how they're operating their plant here, but I took some artistic license and was showing how they could use one of our new features called histogram in R17 to see what shift is having the least amount of overfill. I think they mentioned during one of their presentations they could be a friendly competition or something like that. But dummy data here, so not talking about any specifics on any shift here. This is just for illustrative purposes. You can see here that you could aggregate the data in a certain way here, and all of our users can do this. This is built into Seeq. So you can aggregate, let's say, in this case, amount of overfill or some kind of value over your how you want to bucket it, what kind of bins you want to put this in. And in this case, we put it in bins of shifts here. So my day shift and my swing shift, or we're doing, had this much overfill, and I didn't get, it wasn't in my data here, my dummy data, I didn't see anything in the night shift. So the hours that the signal operates didn't operate in the night shift at all. But as you move the time range, you can see the histogram updates automatically, so you can see these values occur at any time range, so you can do analysis very quickly and see some results here. So that, and in this case, if I want to put in a link here, you can say, look over here. Maybe the day shift had higher overfill than the swing shift here. Maybe swing shift was higher somewhere else. You can easily put the links in there. Let me back up a little bit and talk a little bit more about how Abbott used Seeq to build up this result and actually get insight into their weight control application. So here are all the signals here in this case that were used to build this analysis. So you can see there's a lot of things built, some signals. And what I'll do is, similar to last time, use my journal here to go through step by step on how we built it, how I built it in this case, and the process that Abbott followed. So first I want to add my signals to my blank worksheet here. So what I've got here is a mode of the filler and the weight control process variable and set point. And what I'm going to do next is I added a condition for all the shifts. So I did this using an equation in Seeq, formula in Seeq, and as you can see down in the capsules pane on the right-hand side, I have my night shift here. I'll just kind of click on these. Here's my night shift. Here's a day shift. Here's a swing shift. And you can see they get highlighted up in the display view of Seeq, and that repeats on and on. So I can do night, day, swing shifts, so forth and so on. And we're able to aggregate information within those shifts to bin them in a certain way. Before I do that, let's find out how our filling mode behaved. So I did a value search using our tool to find out what are those times, what are those modes of operation when the filler was actually filling, because that's when I'm actually filling my packages. I don't care about the other times, obviously. I might be cleaning, or machine might be down, might be off. So here are the capsules that you see there that were defining those filling stages here, and I could zoom in on some of them here just to see that, okay, yes, that was indeed filling. That was filling here. So let's do the calculation to see how much overfill occurred during those times. So I created a formula, just a simple subtraction arithmetic type formula, where I'm looking at the process variable minus the set point. And that's that bottom signal on the screen here. So if I remove the rest of them here, I'll just, so you can zoom in and see a little bit easier. These were those times that I had some overfill here. So this is the amount of overfill for those times. And you can see that it's only calculated during those filling modes, which is what we want. And then we're able to aggregate that information so we can totalize the amount of overfill during each filling period over each shift. And that's what the final result that I showed initially was. It was a histogram that showed that information here. So I'll just click on the histogram again. So you can get something like this. This can be shown in real time, updated for any time period very easily. And then, like I described earlier, you can export this information to any other system that you use to do some reporting. One of the new ones in R17 is exporting to PowerPoint. So you can say, do I want to export to full PowerPoint, what have you. So you can figure out how much you want to export. You can export to Excel. So I just wanted to show the PowerPoint export here. I have PowerPoint open already, so this shouldn't take too long to open up here. You can see this case, here's my name of the workbook, and I'm able to just use just as a graphical cut and paste very easily. You can pick it up, go right to your meeting with it, and you can see that the journal information is shown there as well. So just a quick way to export that data there. So that is somewhat pretty close to what Abbott Nutrition was doing and using Seeq to automate those calculations. And I showed some new features there, but happy to talk to all our customers on including Abbott, and how to implement those in the future. I'll pause there for a second. Michael, any questions on that?
Well, I guess three things. One question and two comments. One, same question with respect to the outcome to the customer, right? We've got margins, yield, quality, safety. How is this going to impact their business?
Right. So the impact of the business is, improving the efficiency of the way things run. It can, obviously there's a productivity improvement to doing these calculations in an automated way. But by having this analysis and being able to feed that back into the process to streamline their weight control, I mean, we're talking a direct reduction in scrap losses, so that's operating profit right there. So it's a direct cost to the business to help enable that.
Got it. And second, you mentioned shifts, right? Time periods of interest in this case were shifts, this shift versus that shift. Were those brought in from another system, like from a ERP system or an MES system or some other system, or how did the shifts get defined and then used as the model for dividing up the data?
Yeah. So in my case, I'll just go back, open up Seeq really quick. The way I defined it, I just used a calculation in Seeq. So Seeq has a shifts calculation that you can use to directly create any kind of shifts here. So I'll just kind of open this up, and you can see here that I can define my shifts using a formula. So you could say, every 8 hours, for these 8 hours a day, you can do this. So that's what I did in this case. However, you can grab that information from any other contextual database. So if you do have shift information in a SQL database or in an Oracle database or a CSV file, for instance, you can just bring that in and overlay that just like I did here. So the result is the same view that you see here, where you'll be able to see and click on your shifts, but you can just bring it in a variety of ways, completely flexible.
Got it. The third one is sounds like maybe somebody that's a little bit more recently to Seeq. What's a journal? And I guess the question sort of came through as, these are all filled in. Is everything always filled in?
Oh, right. No, they're not. They're completely blank when you start. The idea is you can create this journal as you go through your analysis. So it's a full rich text editor. So let's just create a new worksheet. I'll just show you really quick here what it looks like. So if I go to this new worksheet, I can create a new entry. You get one journal per worksheet. And then in here, I can add in start my journal. So I can say, start here, and I can add some data. Let me just add a little bit of data to my display here, just to show you to see what it looks like. And then you can add in Seeq links as you go. So you saw me click on links as I went through, and saw the screen update automatically as I went. Then you can type in more text here. And what you're able to do, let me just kind of show you how it looks here. If I want to, if I add in another link here, I can just click on these links, and you see it just shifts back and forth in time, like completely updates the screen back and forth. So you're able to, if you accidentally delete some things or go off on another train of thought, all you have to do is click on that link, and it comes back.
Got it.
So yeah, it's just on the fly. You build it, and you refine it, and then you're able to share, just like I did earlier.
So if you create, I know the answer, but I'll ask it in the form of a question. If you create a journal associated with a worksheet in a workbook, and then I'm later using Seeq somewhere else, can I search on the contents of the journal so I know how to find what you've created for me?
Yes, absolutely. So we want to make everything searchable, and you can actually see I have another filter here called Journal Annotation Contains. So if I want to go, let's see, I think I have some things called shift here. All I have to do is look for shift, and you'll notice here that journal pops up here. If I click on it, it takes me right to the journal. So we make everything searchable, all your signal tags, your data, your assets, your annotations, and your journals. It's all in one place. You can just search for it.
Got it. Okay. Hopefully that answered the question for the person who had it. With that, I guess we're going to jump back and we're going to look at a final use case.
Great. So the final use case is a truck hauling example. So in this case, our customer wanted to visualize how many truck hauls, the amounts that occurred on a given day. And the way that they used to do this was it took a lot of time to generate this report, took weeks to do the turnaround, 6 weeks. And they wanted to get it down so they could do things like reconcile their accounting information, improve their logistics of their trucks, and visualize it in their current work tools in OSIsoft, CoreSight, and Microsoft Power BI. So let me just jump back into Seeq and we'll show you how we did it. So I'll go to my third workbook here, named at the top. And I'll just start here at the truck hauls part, and you can see my final results here. This is what they were after. They wanted to see the amount of hauls per week. So in this case, you can see in that middle row there, this is the amount per week. I had 7 hauls per week here. And they also, at the bottom, they have a delta, how much was taken out from each haul. So you can see they had 187.5 barrels or whatever the units are, they taken out here, and they can track that to do account reconciliation in real time. And this was very useful in a way that they could take all that information that's offline, hard to reconcile with their various systems, and just do it all in one place. So let's show how they did it. So let's start with the blank worksheet and add the tank level to the signal. And one thing I like about this application is there's lots of applications for tank hauling for sure, but there's also other use cases that would, across industries, that this could apply to as well. And the fun thing about this that I like is, as an engineer, the way the math falls out of this is, something like this is easy to spot with the human eye when these truck hauls occur, right? I can see these sharp drops, and that's great, but we don't want a human counting these. We want to define this mathematically. And if you try to do this mathematically based on levels and things, it gets very complicated and starts to fall apart. And if you use spreadsheets or you try to do calculations within spreadsheets, it's very hard. But what we're able to do in Seeq is simply take the first derivative of that signal, just signal as is, first derivative, and if I zoom in on an area, you can see that in this case, you get those sharp negative derivative values because you have a rapid rate of change in the negative direction, and you can see it visually as these dropouts here. And this is just a really nice way of applying math, in this case some calculus, and you get the result you need very quickly. So if I want to capture that information and count these things, all I have to do is create some capsules on those negative value dropouts here. And that's what you see at the top here. Those were those capsules I created over time for those dropouts. Obviously, our customer did. When I say I did it, I just did it on my dummy data, but obviously the customer did it. And then if I zoom in here, I can see that I can do more refined things. Like this is actually one haul. You see it actually maybe paused there. We kind of have that little notch there, but it's still only one haul, so we're able to capture that, do things very sophisticated to make sure that we get exactly what the user wants to see here at the end. So moving on, I'm able to see these capsules. Now all we have to do is simply count these things per week. And that was that bar chart that I showed earlier here. So it's just doing a quick summation of how many of these capsules, how many of these things occurred in any given week. And then we can do a quick delta on those across that tank level on those capsules. So this is, in this case here, you can see I got a big value there, negative 336. That was a big haul there, a bigger haul than the others, relatively speaking. And just a nice way to get those visuals here. And like I did last time I showed you on that last use case with Abbott, is we're able to export to Excel, PowerPoint. We can also export with your OData to any system that supports OData. So Tableau, Spotfire, and also Microsoft Power BI. So all you have to do is click on your export, and we give you a list of instructions here to follow to bring that data into your Power BI system. So you just have to take that URL, paste it in, and you can do it in Excel or what have you, whatever system you want to use. So they were able to use that, and then of course integrate with core site if they want to see the raw signals as they occur in Pi. You can take this and go right to Pi core site there. So that was that use case. Are there any questions there that came in, Michael?
We've got a couple. Apparently, when you were bringing up those tags for the journal demonstration you did, the ad hoc journal demonstration you did a moment ago, there was a question about, wait, is that AF that is that asset framework that you're using, or how can Seeq take advantage of asset framework? So you want to just show that part of the how we use an asset model if a customer had one?
Yeah, certainly. Yeah. So like I said at the top of the presentation, whatever you use in your OSIsoft Pi system, whatever infrastructure you put in place, we can leverage that. And obviously, asset framework's a big one. There's a lot of valuable data there. So those trees that you build, in this case, let me just use my example tree here. You can see that I get these assets, these that we denote as these little cubes here. And you can drill down through your assets. You see we get this breadcrumb path at the top, and then you can simply add your signals just like you would with your other Seeq data. But you use the asset framework, and notice that the asset name comes in that data there. And then once you have that, you're able to use all the features, all the good stuff that comes along with assets, like asset swapping, do asset-based analysis, and that sort of thing there as well. So a very nice thing to use, and we encourage all our OSIsoft customers to leverage what they have in asset framework.
Next question that came in was on the data. Is that really OSIsoft data, or is it raw OSIsoft data, or has that been modified or compressed or downsampled, something like that?
Yeah, it is the raw data. So we use your data as it exists in your Pi system. There's no compression, we don't downsample anything like that. We use it as raw can be. We like it raw. So you can actually get a sense of there's good data integrity. It's exactly what you would expect. It translates well between both systems. If you look at something in Seeq, it's going to match what you have in your OSIsoft Pi system.
Got it. The next question was about writing back. So I guess if we're going to connect to an OSIsoft system, maybe we do this work, right? Calculations or data cleansing or some other manipulation of the data with other data sources and so forth. Can we then make that a new tag or write that back to a tag in OSIsoft Pi?
Yeah, certainly. So I'll just throw up the architecture sheet here that we showed at the top. Yes, so any analysis that you do here in Seeq can be written back into a Pi tag. We have that capability. We get that's a common request. We get asked more and more because our users like not having to do the cumbersome things that you do in spreadsheets and things. They might find something useful, but they want to deploy that result across their current Pi infrastructure. So absolutely, just write it back into a Pi tag if you have a single tag result, and then from there you can do things like do notifications on that Pi tag. So yeah, we leverage that infrastructure just absolutely.
Okay, and I guess one more question, maybe it's appropriate for this architecture view. Okay, where can Seeq run, and do we have any customers on the cloud?
Seeq can run anywhere. Yes, we have customers on the cloud, so we are cloud deployment ready, and you can deploy in the cloud in a variety of ways. You could do it. We do a Linux machine, Windows machine, so you can do whatever cloud infrastructure platform you want. We can also deploy on-premise, so that is obviously a lot of customers like that, have control of their data behind a physical place in their firewall. Or you can do a hybrid approach, whatever. It just does not matter to Seeq. All we need is a server to deploy somewhere that's connected to your Pi data. Typically on level 3 is typically where we see Seeq deployments.
Got it. Well, that is all that's all the questions. So if we want to wrap up, we'll tell people what they saw and tell people what they can do as a next step.
Great. So this is just to summarize some of the process that our customers go through and how to apply Seeq on top of their Pi data is typically there's something that happens. There may be an alert coming in, something requires investigation, or maybe the management team wants to improve the process in a certain way to improve their business, the bottom line. Whatever it is, usually requires some getting the data and wrangling it and twisting it, transforming it a certain way. And in step one, that's what we do in Seeq. So we bring in all your data and connect to it. Obviously, your data is still there. By bringing it in, we just literally bring it in. Don't copy it. We just connect to it. And then you can do all the transforms, manipulation in the time series environment, make it very easy to do. And that's described in step number 2, where you're looking at it, creating your capsules, creating those time periods of interest, you're collaborating, you're investigating, you're making comments on it, annotating, creating your journal, for instance, of what's going on in the data. And then you get the result that you'd like. And then in the third step, you can publish that to a variety of ways, like I showed you some examples. You can monitor that for certain values. If you want to see if a certain condition happens again, you can look at that. And there's a variety of tools you can export to, obviously. And most beneficial of those would be leveraging your OSIsoft Pi infrastructure, and you can use others as well. So we just want to take all of that work that is usually done in the spreadsheet environment and get the engineers doing productive things using their expertise. One of our mottos is your brain, our brawn, and that's part of my job is watching all the people who are experts in their process just unlock these insights. So it's fun, and that's basically the process there. The last slide here, I just would like to throw up on the screen, is where to get more information. So basically the OSIsoft website and the Seeq website, you can go see these presentations that were described here on the OSIsoft website. But if you have any questions about Seeq, specifically, technical, other use cases, you can contact us directly. So look forward to that. I'll turn it back to you, Michael, if there's maybe some other questions came in or any other comments you'd like to wrap up with.
I think we're good. The one thing I would close on is simply for the best thing that we found is, and today, for example, as Brian said several times, we use dummy data to demonstrate the use cases. But what we have found is the most effective way to understand Seeq is to see your own data in Seeq. And so if you have a couple of assets and 4 months of data in an Excel spreadsheet, if you can provide that to us, we can show you what that would look like in Seeq, because we can bring it into Seeq and what you'd be able to find in that data, and it's super effective. So as a next step for those of you watching, if you're curious, okay, now what would Seeq mean? Well, let us show you what that would mean. Just think about a couple of assets, a couple of months. If a non-disclosure agreement or an NDA is required, we're certainly happy to go through that process. But that would really be the best way to understand how much faster Seeq is at helping you find insights, calculations, cleansing, and other work with your OSIsoft Pi data, and really help you get the value out of the investment that you've made in the OSIsoft Pi system. So we'd certainly be happy to have that conversation of interest. You can easily contact through the website. And with that, thank you very much for your time today. If questions or follow-ups, we'd be happy to hear from you. But otherwise, thank you again for joining us, and have a great day.